Oh, there we go. Okay. So, yes, again, I work for IBM in the Austin site. WebSphere Application Server, in its traditional incarnation, it is a platform to run your powerful Java enterprise applications, your EJBs, your web applications, all kinds of specifications released by the JSR groups. The latest thing we're touting is microservices. It's really quite powerful. I've worked in documentation and test, in purgatory for customer support as a developer, and now my latest role is in build engineering, continuous delivery, whatever you want to call it. The team that allows my organization, supports my developers to practice their Agile and DevOps methodologies. So yes, WebSphere Liberty, that's kind of a subset. It's a profile of traditional WebSphere. It's super fast, it's lightweight, composable. It allows developers to easily develop and test their applications. And it was, pretty revolutionary for us when we first created it, starting with 8500 in June 2012. So it was just a handful of developers, cooperating pretty well, just running a few builds per day and, taking in aggregate just a few thousand tests per day. They really weren't, stepping on each other's toes. But 7 years later, we have grown quite a bit, exponentially. Our latest version is 19009, released in September of this year. And so, we got lots more developers. So for example, 100, I think it says 184 contributors to just our offering that we call Open Liberty, and I will get to that in a little bit. So we are running hundreds of builds per day. And each build in and of itself, it's pretty sophisticated. It's pretty comprehensive. There's a lot of processes going on when a build runs, and so cumulatively, that's like millions of tests per day. So we have some pretty unique requirements and demands from a DevOps perspective. Like, we claim support for a combination of approximately 208 operating systems and JVMs. So we have to be running builds, these massive builds, to make sure that that support statement is good and verifying all that. Our service strategy. So, we have customers who are like on this fix pack that is like super old, like maybe a decade old, and they refuse to move up. I mean, who can blame them? And if they want a fix, we have to be able to provide that fix to that customer. And so we need to have those build and test environments at the ready to be able to provide those fixes. So Open Liberty, as I mentioned, that is like, we took a huge bite out of WebSphere Liberty. We took it out of that commercial offering, and we stuck it in open source. It's in a GitHub repository, and so it's publicly accessible. People can contribute to it. It doesn't just have to be IBMers contributing to it. So that was a big. That created some unique challenges for us, my build team. And then starting in January of this year, we started releasing a new version of the product every month versus our old cadence of every quarter. So that has required our builds to be running as pretty tight ships, and our runway is a lot more narrow than it was before. So let's talk about that build. On average, the mileage may vary just depending on a number of factors because there's so many moving parts to a build, about 8 hours. So of course, in its very simplest distillation, compiles the product, compiles those tests, run those tests. So unit tests, build verification tests, functional tests approximately 70,000 tests just per build. And if you were to string those tests sequentially end to end, it would be about 60 hours runtime. But of course, that's not realistic and feasible for us, so we have to run those in parallel. All right, so I'm going to talk about the pipeline, development, delivery, production. So you got this developer. She gets in her requirements from a customer or the software architect, or there's a bug report. She builds her code. She codes it, she builds, she runs her tests, and maybe, it just takes a few cycles, or maybe it just takes one try for her to get it right. So just within that column, that phase alone, the developer experience was not ideal. There was just a lot of headache about the documentation for all our processes. We're pretty large. Oh yeah, I forgot to mention that. We are spread out across multiple cities, multiple geographies, multiple time zones. I have a team that I work closely with in Hursley, England. They're 6 or 7 hours ahead of me. So that creates, some challenges there. So, we need to be able to have these instructions for new people, for current people, to keep, current with our processes. And, we were using this proprietary wiki-based website that just was inefficient. It was hard to manage. It was just getting obsoleted pretty much instantaneously. And the need for the developers to build, run this comprehensive build on their local machine, that was just asking too much. And if they just wanted to run, this narrow test that just, exercise their code change, they had to go through this complicated test environment setup on their local systems. So yeah, that was just, too much. Those were big impediments. How much time do I have left? Because the timer, it seems to be stuck. 15 minutes? Okay. Oh, I have to go back. How do you go back? Okay, so what have we improved upon that, those non-ideal conditions for the developers? We've moved our documentation away from that proprietary website to the wiki space in our GitHub repository. So that was really easy for anyone who's a member of the organization to update those instructions and keep current with reality, with what people were really doing. Allowing people to just quickly build the minimal product, and with alternatives of letting them run some extra build steps to further verify, exercise their code changes if as appropriate. Fast and easy test setup and execution, and this was my personal favorite, heaven sent for me. We moved away from this clunky source code management tool that was GUI-based, is GUI-based, it's still around, and didn't have good command line and API options that lent itself to automation very well. So we moved away from that to GitHub, and that's just been a dream. All right, so developer wants to deliver her code. She opens a pull request. She requests a code review from a peer with subject matter expertise, and then she, if all is good, she merges to the integration branch where people are dropping in all their code. It's like a staging area before it moves on to master branch, or she starts over if there's a problem found during the code review. And from there on, it moves into the continuous build. And the continuous build is what, tests, incorporates all those new code changes and makes sure that, nothing has disrupted the other. And the point of it is, to sanitize everything. And then, if it passes well enough, it pushes all those new code commits to the master branch. And from there on, the release build, it takes all that, those good code changes, and it, does pretty much the same thing as a continuous build does, builds code, runs a bunch of tests, a bunch of, other things concerning documentation, et cetera. And it is there to produce the final product for, the waiting customer to consume. So all is good. But in theory, people were constantly breaking those continuous builds. Maybe they weren't properly testing their code changes well enough. So the continuous builds would be read, and therefore that would mean everyone else was at a standstill. No one else's code commits would be pushed into master and go through that pipeline to make it to production. So we had to introduce the practice and the concept of the personal build, which just takes the known good state of a stable state of the code base, and then slaps on top of that that individual developer's code changes, and does the rigmarole, et cetera, et cetera. Okay, so possible paths, merges to integration, blah 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 blah. The rest, or starts all over again. And still problems despite the personal builds running. We would have to constantly revert hard failures or failures, just revert those individual code changes so that the continuous builds can run and pass, and things can flow to master and make it to the release build. So let's talk about the build breaks. We break down our build breaks into two categories. The hard break, it's any compilation or unit test failure, and what's not mentioned there is build verification tests failing too. Those are hard breaks. We need to fix those immediately. And then the functional tests, which are the more complicated, mimicking of customer scenarios. If they fail more than a third of the time, we consider them hard breaks, and we treat them, accordingly with the appropriate priority and severity. And then intermittent failures, which kind of break my heart because they occur a third or the less of the time. But they can just turn a perfectly green build. They can make a build that would have been fine and make it fail. So yeah, they're a little heart-wrenching. But we need those developers to fix those failures. So overall, on average, we have a 99.8 passing rate, which sounds wonderful. That sounds great. But if you take into consideration, that we're running so many builds per day and there's millions of tests running per day, I mean, that translates into a lot of test failures, a lot of individual test failures per day. Okay. So to kind of, manage this chaos, wade through this massive failure, we had to introduce the practice of build monitoring. So again, my team in Hersley, they're brilliant. They created this really powerful tool that uses, automation, big data analytics, artificial intelligence to analyze, each and every build, identify if a test failure is a known pre-existing problem, and maps it, to a known existing build break issue, or it can point out, hey, that's a new test failure, and there's something relatively recent, relatively new that is behind that. But automation, artificial intelligence, that's just not enough. We need to augment that with the smarts and intuition of a human being, visually looking at the builds. So we have the system of rotating build monitors every 2 weeks. So every developer in the organization has to feel the pain and responsibility of looking at these builds. Okay, so yeah, we have to rely like on an actual human being's ability to understand, to be smarter about, okay, what's a real failure and what is due to some network blip, for example, or some other weirdness that's going on with the build infrastructure. So, they find those hard breaks, they revert the code changes that were, the cause behind them. They identify intermittent failures accordingly, and, they get the appropriate eyes on them to resolve those. So in handling build breaks, what hasn't worked was expecting perfection of each and every build. I mean, that's just not realistic. Our builds are dependent on all kinds of things like, an artifactory repository, for example, that we don't manage. And if there's an outage, that's completely out of our control. And it's just not realistic to expect every build to pass and be green. And then the practice of automatically reverting every code change that was included in a build that had failures. That was like penalizing the many for the sins of one or the few. So that was a big hindrance to people making progress, to getting their code out into the final product. That was not a good practice. And the practice of automatically retrying all failed tests in all the builds, I mean, that was just too much. That added so much time to all the builds and just consumed too much resources, created so much load. So our improvements over that has been, the introduction of personal builds, reverting the hard build breaks immediately and only selectively retrying test failures in certain builds, not in only selectively retrying tests in certain builds, not the personal builds, just the continuous and release builds, to rule out if something is due to a flaky test bug or some other blip. So that's our flow, possible paths there. But the personal build, it's still a bottleneck to the developers' ability to make progress, to our velocity, our rate of being able to deliver new functionality. Some common complaints about these personal builds: they're too slow, too clunky, complicated to request a personal build, difficult to understand, okay, this intermittent failure, is that caused by my new code change, or is that caused by someone else's recent code changes? Is it due to a flaky test, or what is it? And a comprehensive personal build is not needed for every code change. I mean, we can't prescribe a one-size-fits-all medication to every change. I mean, maybe a change is just a simple one-line change in a messages file, and it doesn't necessitate running 70,000 tests just to test that very simple change. So improvements upon the personal build. All right, I'm going to disagree with Andy a little bit on this. He was saying that, our improvement was that we are not requiring people to run personal builds anymore. We had this automation tool that was really draconian, pretty stringent. It was punitive. It made sure that you need a personal build for this new code change, no matter what. Yes, that was not good, but our general rule of thumb is personal builds should be run for everything. But we needed to trust that the developers were going to do that, that they were going to run their personal builds, they were going to do the right thing. So we got rid of that tool that enforced that requirement. And we introduced this automation that allowed people to just, add a comment in their pull request, #build, and that would do all kinds of things under the covers for those developers. It would tweak those knobs and bells and whistles so that developers didn't have to mess with that, and it just makes their jobs a lot easier. Yeah, and customizing their personal builds so that the tests run, all the build activities run, it's appropriate for their changes. Again, if I have a message change in something in like the EJB container, like maybe this part of the product, it's totally not affected by that message change. Oh, and that automated build monitoring tool, it allows the developers to understand, hey, this test failure is not mine. It's caused by something else. It's already a known problem. All right, so there's the possible paths. The quick merge, I disagree with that. I have to respectfully disagree with that. But that is possible. There's nothing to stop somebody from just merging into integration, though, we would have a stern talking to with that person if he did not run a personal build and ended up breaking the continuous and release builds. But like my Hersley colleagues, they call it have a quiet word with that person. They're so much more eloquent than I could ever be. All right. So other things we have tried. What didn't work? The mindset of everybody owning the build. What's that saying? With great power comes great responsibility. That's the wrong saying. When everybody owns something, nobody owns it, or something like that. Do I have it right? More or less, right? So we were expecting the developers to feel like, yeah, you need to understand this build flow. You need to understand what the scripts are doing. And everyone needs to pitch in and manage things accordingly. And that's, again, our builds are pretty sophisticated, comprehensive, a bit massive. It's just not a realistic expectation for everyone to understand what's going on. Just like, I'm not going to know what's going on with, that kernel code, Jack's WS code, for example. Okay, and the mentality of writing product code now and dropping that in and then introducing automated tests later. I promise I'll get to it later. And I'm sure everyone in this room will agree. Let me ask you, do you think that's a good practice?
Never get to it.
That's right. So that was not good. We needed to get rid of that. And then code bloat, just writing code to accomplish your objective and just like making it work now because you're so tired and you're trying to get your functionality out to the customer, and you'll clean it up later. That mindset. So that man, John, yesterday, who gave a talk about the infamous DevOps team and avoiding them. I'm sorry, I need a red pen to cross that out. Dedicated DevOps team, Andy means my team, the build team, the team that produces the tools and supports the processes and all that to enable all of my developers, my organization's developers to practice DevOps methodologies and philosophies and be as agile as possible. Yeah, we introduced my team, the continuous delivery team. Our build infrastructure, using virtual machines and containers as appropriate, and the automatic provisioning of those resources because we run so many builds. Observability, test metrics, providing data and analysis about the state of failures, their performance, or, what's going on if, this certain bucket here has been failing, started failing, at a certain point in time. That sort of data has been very useful. Yeah, and we were on IRC before, and anybody here heard of Same Time or use Same Time? Just a few hands. Yes, it's kind of wonk, wonk, embarrassing. Now we're on Slack, and I like it. I love the Jiffy. Uh, it's a great tool for collaborating, for communicating, especially with my guys in Hersley and wherever they are, China, India. It's really powerful, but some people just can't stand the mess of messages, and I understand where they're coming from. Okay, so the problems that we still have. Yes, nothing is perfect. I cannot lie and say that everything is utopia for us. Our builds are still pretty long, and that man back there, Ethan, he that's his pet, is to push that time down and make them more performant. We're constantly working on that and brainstorming about ways to do pare down that time. Infrastructure reliability, still a lot of flakiness. The network, for example, the OpenStack clouds upon which we rely. Sometimes there's something, off about them. Those intermittent failures, I just started coloring my hair since working here relatively recently. And yeah, they're turning my hair gray. They're wrenching. Okay, and real quickly, it's not on the slides. We're still pretty siloed in terms of our functional expertise, our subject matter expertise, and our responsibility. But that's just what works for us. I cannot, if I wanted to, in theory, I could go ahead and mess around with, the kernel code or microservices, and I could just change something, I could deliver it, but, I would break that sucker so fast. So yeah, it just takes time and resources to build up the knowledge for all these different functional areas in our product, and that includes the build. It's pretty massive. Okay, 1 minute. Okay, perfect. So I'm Wendy, and if you have any ideas for me or questions, you want to scold me, just come find me or contact me there. Thanks a lot.
Thank you. Thank you. Good job. I really appreciate